Now that you've had the chance to think about statements, we're going to talk about a specific type of statement called a conditional statement. And actually, the first thing we're going to do is take a step back and talk about the use of models to help understand concepts. It's something that I'm going to be doing throughout the semester, so I figure now is a good time to talk about it, to give you a heads up on that. Then we're going to explore what conditional statements are. And what I mean by conditional statements is those are statements that use the if-then construction. So anytime you have a statement that has if something, then something else, that's a conditional statement. And then we're going to determine when conditional statements are true and when they are false. All right, so before we start talking about conditional statements specifically, I want to talk about using models. And we do that when we have some abstract concepts that we're trying to understand, but are very difficult to understand. And I should mention, this can happen even when the definitions are clear. It's very possible you look at a definition, you say, yeah, that makes total sense to me, and then you see it used in an example, and you say, what the heck's going on? That's not uncommon in math. And so what happens is models are a way of navigating the gap between the definition of something and how we understand it. So models are a concrete way to think about a mathematical concept that helps us understand it better. It isn't a formal definition, it's not supposed to be. It isn't an example necessarily, but it is something that helps us turn definitions into examples using metaphors and other things that we can understand. So I hope I have already used Peeves as a model for checking your proofs in our first course. If I haven't, that would actually be a really good question for either the discussion questions on Blackboard or in class. So feel free to ask me about that if I haven't told you already, or, if you forgot, that's fine. But anyway, if we've talked about Peeves, that is a particular model that we've used before. I will be using many models this semester for various definitions and concepts. Somewhere between like 20 and 30 different models for concepts that are important to understand and difficult to understand as well. I should tell you that this using models isn't just something that students have to do, but I don't have to do, that I'm too smart to do or something like that. No, all mathematicians use models. I use models all the time, and I use it in my research as well. So it's not just that I use them when I teach, I use them when I do my own math to help me understand concepts that are difficult for me. And one of the things I would do is, you won't be tested on this or anything like that, but I encourage you to come up with your own models for different concepts, especially things that you have trouble with, that you have trouble understanding, that you have trouble using in proofs. I encourage you to try to come up with your models, and if you're so inclined, it would be nice if you would share them with me so that I can share them with other people, if you're comfortable. All right, so let's get back to conditional statements. But actually, before we even talk specifically about conditional statements, I want to talk generally about when a statement is true. Now, just remembering from the last video, a statement is a sentence that is either unambiguously true or unambiguously false, right? And so one of the things that we're going to worry about is, given a statement, when is it true and how do we show it? Well, here's a good model for understanding how a statement is true, or when a statement is true. I call it the liar model. And what it says is that a statement is true precisely when you are not lying when you say it. And I like saying it this way because it helps us understand things in a way that maybe we don't understand them when we think of this as like this truth, this sort of purity kind of thing. So, first of all, it indicates that looking at what lying means in the context of the statement, that's important for figuring out when a statement is true and when it is false. And it's really important to understand that true does not necessarily need to be virtuous. It doesn't mean you're a good person. It's not like good persons say true statements and bad people say false statements. It's that all that true means is, you can say a true thing and still be a scoundrel. You can actually say a false thing and not be a bad person at all. You just said something that was a mistake. All that saying a true thing means is that you are technically not lying when you say it, right? All right, so now let's look at conditional statements. A conditional statement is a statement of the form, if something, then something else, right? And I'm, of course, going to give you a model to understand conditional statements. And the statement that I want to sort of analyze is the statement, it's a conditional statement. If my kids behave, then I will give them cookies. This I find to be a really helpful example in understanding conditional statements more generally. So, the question is, when is this false and when is this true? Or another equivalent way of saying it, when am I lying to my kids when I say it? And when am I not lying when I say it? Well, here's what happens when I'm lying. If I'm lying, this is exactly what happened. It means my kids behaved, but I did not give them cookies. Right? That's exactly what it means for me to be lying. And what does it mean for me to be telling the truth? And literally anything else. Now, that might be a little bit troubling to you because, of course, I know some of you may be looking at that and saying, wait a minute, what if my children don't behave, but I do give them cookies? Then is the statement a false statement? Well, I got two things to say about that situation where I say if my kids behave, then I will give them cookies. When they don't behave, and I give them cookies. First of all, you are absolutely right that I am being a bad dad, right? It's encouraging bad behavior. Of course, that I shouldn't be doing that. That's not the question. The question is, am I lying? And the answer is, I am not being a liar when I say that, right? I am being so that means I can be honest, being not a liar, and a bad father at the same time. That can happen. But the question is not whether am I a good dad or am I a bad dad. The question is, am I lying? Am I not lying? Okay, so this is how conditional statements work, right? If you have P and Q that are statements, a conditional statement is of the form if P, which is one statement, then Q, which is another statement. This is another way of taking two statements, P and Q, combining them into one statement, if P, then Q. Now, when is it going to be false? I like looking at false first because I like looking at the lying. The lying means that P is true and Q is false, right? You're saying if P is true, then Q is definitely true. And if P is true and Q is false, that makes me a liar, or you a liar if you're the one saying it, right? And then true is literally all other situations. And so I'll go ahead and enumerate all those situations just so you understand what they are. If P and Q are both true, then if P then Q is true. That's usually the one you're thinking about the most when you're thinking about this one, if they're both true. It is also true if P is false and Q is false, right? And then the final one is if P is false and Q is true, it is also true. That was the one where you were unhappy with me because my kids didn't behave, but I still gave them cookies, right? But if P is false and Q is true, then if P then Q is a true statement. All right, so now that we've discussed how to work with conditional statements, I think you're ready to work on the activities. It's the PDF file that comes with this video. It is called Conditional Statements.